now we will discuss the arithmetic series. So by definition, sequence is progression, right? So when it comes to arithmetic series, it is the sum of a sequence in which each term is computed from the previous one by adding or subtracting a constant. Okay? So yun naman yung tinatawag nating arithmetic series. Now, we will find the sum of the following arithmetic series. We have 4 problems. So in letter A, 411 to 16 terms. Letter B, -9, -1 to 8 terms. Letter C, 5913 to 101. And letter D, 80, 77, and 5. Now in letter A and B, given are the first 2 terms and the nth term. While in letter C and D, given are the terms, let's say first 3 terms and the last terms. Okay, so how can we find the sum of this following arithmetic series? Going back to the problem, letter A, 411 to 16 terms. Now, we will first recall the formula in getting the arithmetic series. Now, we have the formulas. So, S sub n is equal to n over 2 times the quantity of 2, a sub 1 plus n minus 1 times d. And the other formula is S sub n is equal to a sub 1 plus a sub n all over 2 times n. So, and here is the nth term, while the a sub 1 is the first term. This is the common difference. A sub n is the last term. Okay? Now, if in the given, for example, in letter A, 411 to 16 terms, so we have a sub 1. Since this is arithmetic series, we can automatically find the difference by simply subtracting 11 to 4. So, assuming that these are all arithmetic sequence. Okay? Then this 16 terms is the number of terms. So that means in this sequence there are 16 terms in total. Okay? So what formula is appropriate to use here? So that is the first one. Okay? So the first one, because we knew that n is 16 and we knew that a sub 1 is 4. Okay? And the common difference will follow later. We cannot use the second formula because we don't know what is the last term. So in this case, what is the value of the 16th term? So we will use the first formula. So we will now compute. So again, we will use the first formula. And the formula again is S sub n is equal to n over 2 times 2a sub 1 plus the quantity of n minus 1 times the common difference. So again, first thing to do after writing the formula is to know what are variables involved here. So a sub 1 is our first term. Our n is the nth term, which in this case 16. The common difference, simply subtracting the last term to the previous term, 11 minus 4 is 7. Then do the substitution method. We will now substitute S sub n is equal to n divided by 2 times 2 times a sub 1 plus n minus 1 times the difference, which is 7. Then do the groupings. This is 16 divided by 2, that is 8. 2 times 4 is 8. 16 minus 1 is 15, multiplied by 7. Do the multiplication. Copy, copy. 7 times 15 is 105. Then do the addition. Copy, copy. 8 times 105 is 113. Then do the multiplication. 8 times 113 is, so 8 times 3 is 24. Carry 2. 8 times 1 plus 2, 10. Carry 1. 8 times 1 plus 1 is 9. Thus, the sum of 4, 11 to 16 terms is equal to 904. Let's now proceed to letter B. So this is same case with letter A. So same formula applies in letter B. That is S sub n is equal to n over 2 times 2a sub 1 plus n minus 1 times the common difference. We need to know the a sub 1. In this case, a sub 1 is the first term, negative 9. Our n is 8 terms, that is 8. Common difference is negative 1 minus negative 9, or negative 1 plus 9, that is 8. Then plug into the formula. S sub n is S sub 8 is equal to n over 2 times 2 times negative 9, the first term, plus our n minus 1 times the common difference. And then simplify. 8 divided by 2 is 4. 2 times negative 9 is negative 18. 8 minus 1 is 7 times 8. Do the multiplication. Copy. Copy. 7 times 8 is 56. Do the addition. 56 plus negative 18, or simply 56 minus 18 is, okay, copy 4 first. So negative 18 plus 56 is 38. Okay, so that is 38. 56 minus 18 is 38. Then do the multiplication. 38 times 8. 8 times 4 is 32. 4 times 3, 12, plus 3, 15. So that means the sum of the 8 terms is equal to 152. Now, let's proceed to letter C and letter D. Now, in letter C and letter D, the given is the first term followed by the last term. We do not know what is the common, we do not know the number of terms here. Okay? So what should we do? So in this case, we can use the first or the second formula. Okay? So let's try to solve it using the third formula. S sub n is equal to a sub 1 plus a sub n all over 2 times n. Okay? Since we have a sub 1 here, which is 5, and our last term is 101, we need to identify what is our n. And now, what term is 101 in this sequence? We do not know. We will go back to the arithmetic sequence. Remember that the formula of arithmetic sequence is a sub n is equal to a sub 1 plus n minus 1 times the common difference. So we will use this formula in order to find the n here. Okay? So a sub n in this is 101. Our a sub 1 is 5 plus n, which is the unknown, times the common difference. So 13 minus 9 is 4. 9 minus 5 is 4. The common difference is 4. Then do the distribution. So 4 times n is 4n. 4 minus 1 is 4. So again, this part is utilized in order to find the n here. Okay? Because we don't know what is the nth term in this sequence. We know that the last term is 101, but we don't know what is the number of term here. Okay, so let's continue. So transpose 5, transpose negative 4. 5 minus 4 first is 1. Transpose or add negative 1 both sides to get 100. That is equal to 4n. Then divide by, or we can swap this one Then to find the value of n, divide by 4. 100 divided by 4 is 25. So that means we have 25 terms in total here. Okay, so we have 25 terms in total. From 5, 9, 13 until 101, we have 25 terms. Now we can use now the formula. We need to plug these values. So that means S sub 25 is equal to A sub 1 plus the A sub n all over 2 times the n. Then 5 plus 101 is 106 divided by 2. 106 divided by 2 is 53. 53, then multiply by 25. Okay, so 53 times 25 is equal to 1325. So that means that the sum of this sequence starting from 5, 9, 13 until 101 with 25 terms is equal to 1325. Last item, letter D, 83, 80, 77, 5. So same case with letter C. Okay, so we will use the formula S sub n is equal to A sub 1 plus A sub n all over 2 times n. Know the value. A sub 1 is 83. Our n is, we don't know, and our A sub n is 5. So we don't know here what is the n term. We know that the n term here is 5, but we don't know the value of n. So we need to find using the arithmetic sequence. Again, arithmetic sequence is equal to A sub n is equal to A sub 1 plus n minus 1 times the common difference. Okay, so again, we will use this part to determine the value of n. So our A sub n is 5 is equal to A sub 1, which is 83, plus n, which is unknown, minus 1 times the common difference. 77 times 80 is negative 3. 80 minus 83 is also negative 3. Hence, the difference is negative 3. Okay, then do the distribution. Copy. Negative 3 times n is negative 3n. Negative 3 times negative 1 is positive 3. Copy. 83 plus 83 is 86 minus 3n. We will transpose this one to the other part. So 86 or 5 minus 86 is negative 81, which is 3n. Now, in order to find the value of n, we need to divide negative 81 by negative 3. So negative 81 divided by negative 3 is 27. So that means from 83 to 5, there are 27 terms in total. Thus, n is 27. Now, we can now plug to the formula. Okay, sorry for the distortion. So we will now plug. S sub n, that is S sub 27, is equal to A sub 1 is 83 plus A sub n, which is 5 all over 2 times the number of total of terms, which is 27. Okay, copy. 83 plus 5 is 88 divided by 2 times 27. Half of 88 is 44. 44 times 27. So copy. 44 times 27 is 1,188. So that means there is a sum of 1,188 in this sequence.